हेलो एवरीवन, कैसे हो आप सभी लोग। आई होप सब अच्छे होंगे। सो टुडे आई एम बैक अगेन विद द लेक्चर सीरीज ऑफ द वेक्टर्स एंड 3D ज्योमेट्री। तो आज का जो लेक्चर है विल बेसिकली डिस्कस अबाउट द वेरी इंपॉर्टेंट टॉपिक ऑफ वेक्टर एंड द इंपॉर्टेंट कॉन्सेप्ट ऑफ वेक्टर इन 3D ज्योमेट्री बेसिकली इज अ क्रॉस प्रोडक्ट। नाउ इन वेक्टर एंड 3D ज्योमेट्री विल सी दैट वी विल डेफिनेटली यूज दिस पर्टिकुलर कॉन्सेप्ट ऑफ द क्रॉस प्रोडक्ट टू जनरेट अ परपेंडिकुलर वेक्टर टू बोथ द वेक्टर्स। ठीक है, और ये वाला जो कॉन्सेप्ट है ये आप प्लेन्स में भी यूज़ करने वाले हो। जब आप 3D ज्योमेट्री में प्लेन्स पढ़ोगे या फिर कोई भी डिफरेंट टाइप्स ऑफ 3D ज्योमेट्री का विजुअलाइजेशन क्वेश्चन करोगे जहाँ पर बोला जाएगा कि दो स्ट्रेट लाइन्स है एंड यू हैव टू जनरेट अनदर पर्टिकुलर स्ट्रेट लाइन सच दैट पर्टिकुलर स्ट्रेट लाइन इज परपेंडिकुलर टू बोथ द स्ट्रेट लाइन। तो इन दैट पर्टिकुलर सिचुएशन ऑफ क्वेश्चन द वेक्टर प्रोडक्ट एक्चुअली प्लेज अ वेरी इंपॉर्टेंट रोल। तो आज की वीडियो में हम लोग वेक्टर प्रोडक्ट के बारे में देखने वाले हैं। ठीक है, सो बिफोर स्टार्टिंग ऑन विद टूडेज लेक्चर आई गॉट सम कमेंट्स फ्रॉम यू स्टूडेंट्स रिगार्डिंग कि भैया मेरे को मैथ्स का पोर्शन कैसे कवर करना चाहिए। सो आई वांट टू नो ओके हाउ मेनी ऑफ यू आर देयर एंड व्हाट इज़ योर करेंट प्रिपरेशन स्टेटस। ठीक है, और कितने बच्चे हैं जैसे जिनको जेई 2024 देना है या फिर जेई 2025 को देना है। ठीक है, हाउ मेनी ऑफ यू स्टूडेंट्स एक्चुअली नीड दैट पर्टिकुलर वीडियो रिगार्डिंग टिप्स and how to just enhance the calculation speeds and even how to tackle the JEE mains and JEE advanced portion of mathematics. ठीक है, तो of this particular content I'm thinking to make particular video regarding the how to cover the entire syllabus of JEE mathematics in 6 months or like how to prepare for mathematics portion especially. Okay, so let me know in the comment section below. So इस वीडियो को कमेंट में जाके कमेंट करना कि आप लोग को वीडियो चाहिए या नहीं चाहिए और what is your present preparation status. ठीक है, so that I can access all of you individually. ठीक है, I want to know my audience better and in that particular situation I can help all of you. Okay, so with this let me get started. So my name is Sirsha and I am a BTech student at IIT Kharagpur. Okay, so today's goal will basically be on the, so I forgot to write about the today's goal. So today's goal will basically start with, so this will basically we will start with vector product. And before moving on to vector product, we will be discussing some important question regarding the algebra of vectors. Okay, and then we move on to solve some basic questions of JEE mains regarding the vector product. Okay, so with this let me get started. So in the first question, okay, we have basically a question which is basically relates the previous class. तो जो बच्चे इस वीडियो को डायरेक्टली देख रहे आ रहे हैं, ठीक है, मेक श्योर करना कि आप वीडियो को तभी देख रहे हो आप वीडियो को तभी देख रहे हो जब आप पहला वाला वीडियो देख रखे हो। ठीक है, विदाउट वाचिंग ऑल द वीडियोस ऑन द प्ले लिस्ट यू कांट डायरेक्टली कम एंड जंप ऑन टू दिस पर्टिकुलर लेक्चर्स। ठीक है, आपको समझ में उतना अच्छे से नहीं आने वाला है अगर आप हर एक लेक्चर को कॉन्टिन्यूस में नहीं देख रहे हो। ठीक है, देन इन दैट पर्टिकुलर सिनेरियो यू कैन मिस आउट सम ऑफ द इंपॉर्टेंट प्रॉपर्टीज और कॉन्सेप्ट। ठीक है, एंड यू वोंट बी एबल टू अंडरस्टैंड व्हाट आई एम एक्चुअली गोइंग and teaching in this particular lecture series. Okay, so with this let me get started with this question. So in this question it has said, तो देखो मैथ्स का क्वेश्चन है, सबसे पहले तो क्वेश्चन को अच्छे से पढ़ो। कोई भी कॉम्पिटिटिव एग्जाम में ना क्वेश्चन को ढंग से पढ़ना एक अच्छा आर्ट प्ले करता है इन ऑर्डर टू गेट योर एग्जामिनेशन क्वेश्चन को करेक्ट करने के लिए। ठीक है, तो क्वेश्चन को सबसे पहले पढ़ना चाहिए। सो इन दिस पर्टिकुलर क्वेश्चन वी सी दैट देयर इज अ वेक्टर a vector and there is another vector which is b vector and it is defined in some terms of scalar, okay, unknowns. There is b1 and b2 and similarly there is another vector that is c and b, the three vectors such that the projection of b vector on a vector is basically a vector. So what does the projection of a vector means? I already talked about the projection जब ले रहे थे वो basically scalar result दे रहा था, but in this question this यहाँ बोल रहा है कि एक projection of another vector is a vector, that means the magnitude of this projection will basically equal to a vector. So from here and also it is said that if a vector plus b vector is basically perpendicular to c vector and for perpendicular condition you already are very sure that आपको क्या लगाना है, that is scalar product लगाना है। ठीक है, and equate the result to 0. So let us solve this question. So from the very first condition in the question what is said basically, अगर आप देखेंगे ना तो b vector का जो projection है, if I assume this is b vector and this is a vector in such fashion that the angle between both the vectors is theta, so the projection will be basically this particular length and this particular length and this particular vector is actually a vector. So from here this is actually perpendicular thing and this particular length, this is OA, is actually the a vector which is mentioned in the question. So from here I can use the projection formula. So I hope आपने last lecture से projection formula याद कर रखे होंगे। अगर याद भी नहीं रहा होगा तो कोई दिक्कत वाली बात है नहीं, basically it is derived from the dot product only. So from here if I apply this particular thing that is a dot b एंड जिसके ऊपर प्रोजेक्शन फेंक रहे उसको उसका मॉड्यूलस से डिवाइड करना है। आई एम प्रोजेक्टिंग इट ऑन द ए वेक्टर, सो आई विल डिवाइड इट बाय द मॉड्यूलस ऑफ ए वेक्टर एंड दिस पर्टिकुलर जो मॉड्यूलस का वैल्यू है एंड इफ आई टेक द मॉड्यूलस ऑफ दिस पर्टिकुलर थिंग टू गेट द पॉजिटिव साइन, बिकॉज प्रोजेक्शन जो वैल्यू आएगा ऑब्वियसली पॉजिटिव साइन मुझे चाहिए। ठीक है, आई वांट द मैग्नीट्यूड बेसिकली ठीक है, and is equal to the basically the magnitude of a vector. So from here I can write this particular thing. So if I talk about the magnitude of vector a, what can I write about the magnitude of vector a? That is basically square root of 1 plus 1 plus 2, that is basically equal to 2 units. So from here what I see, that modulus of a basically equal to 2 units. So from here can I compute the dot product and write this as, if I compute a dot b, I can multiply the individual components such that b1 plus b2 plus 2 is basically equal to, and if I take this modulus of 2 on this particular side, and if I take this, and then this result will be 2 into 2, that is basically equal to 4. So from here I will get an equation that is b1 plus b2 is basically equal to 2, and if I label this as equation number 1, and let us solve other condition that is given in the question. So other condition is basically a vector plus b vector is said that this particular vector is perpendicular to c vector. So from here I can write the condition that a vector plus b vector, if it is perpendicular to c vector, then its dot product with c vector will basically be equal to 0. So from here if I solve this particular condition, then I will get the result as, in the a vector plus b vector is basically equal to 1 plus b1 I cap plus 1 plus b2 j cap plus 2 root 2 k caps, and this particular thing is equal to a vector plus b vector. And from here if you compute the dot product with the c vector, what the result will you get? You will get is basically 5 multiplied by, because c vector is given as 5 I cap plus j cap plus root 2 k cap. So from here if you compute is 5 times of 1 plus b1 plus of, this will be basically 1 plus 1 times of 1 plus 1 plus b2 plus of 2 into root 2 times into root 2, that is basically 2 into 2, that is basically 4. So from here you will get the result, that is plus 4. Okay, plus 4 is basically equal to 0. So if you compute this particular result from here, what the result will you get? So from here if you compute and equal it to 0, the result you will get from here is basically 5 plus 5 times of b1 plus 1 plus b2 is basically equal to minus 4. So from here if you compute the result you will get 5 times of b1 plus b2 is basically equal to minus of 10. So this is labeled as equation number 2. Now from here I got the b1 plus b2 is basically equal to 2, and 5 times of b1 plus b2 is basically equal to minus 10. So from here if I solve both the equation 1 and 2 simultaneously, then I will get the relation as 4 times of b1 is basically equal to minus 10 minus of 2. If I put this particular result over here, b1 plus b2, then I can write is 4 times of b1 plus b2, and b1 plus b2 I replace it with 2, then I will get minus 10 and minus 2 on this particular side. So from here the result of b1 is basically equal to minus 3. If I say what is b1, then you will say the b1 is basically equal to minus 3, and similarly if I say talk about what is b2, you will say this is b2 is basically 5. Okay, so you will say b2 is basically equal to 5. So from here if I put this particular thing over here, I can see that this is satisfying the second equation as well as first equation. From here what vector will I get? The b vector is basically equal to, then from here if I, what is the b vector? The b vector is basically equal to minus 3 I cap plus 5 j cap plus root 2 times of k cap. Now from here if I try to compute the modulus value of this particular vector, if I try to compute the modulus value of this vector b, then I will get the result as, that is 9 plus 25 plus 2 over here, and if I compute this, what result will I get? This is basically 11, and this is basically equal to 36. Root 36 is basically equal to 6 units. So from here the correct answer to this question will basically be option number B. आई होप आप इस क्वेश्चन को समझ पा रहे होंगे, ठीक है. सो with this particular question you can see that this types of question are actually asked in JEE mains paper. Okay, this is basically JEE mains question of 2019. Okay, so I took up an easy question to illustrate कि जो टॉपिक्स पढ़ रहे हो उसका क्यों यूजेस है, ठीक है. आप क्वेश्चंस देख रहे हो कि कैसे कैसे क्वेश्चन पूछा जा रहा है, ठीक है. सो विद दिस आई होप यू विल टेक केयर ऑफ दिस क्वेश्चन, एंड ऐसा टाइप का क्वेश्चन काफी बार एग्जाम में रिपीट होता है, ठीक है. प्रोजेक्शन का कॉन्सेप्ट, परपेंडिकुलर कॉन्सेप्ट, ओके, एंड दिस टाइप्स ऑफ क्वेश्चन है एक्चुअली द इंपॉर्टेंट क्वेश्चन ऑफ स्केलर प्रोडक्ट. Okay, so with this let us move on to the next question, and I took this question just to explain you basically about what is the geometric importance of vectors. ठीक है, अब वेक्टर जो algebra पढ़े थे जैसे प्लस, एडिशन, सब्ट्रैक्शन, उसका यूज कहाँ कहाँ आ रहा है, ठीक है. तो उसका यूज बेसिकली टू सॉल्व द ज्योमेट्रिक रिजल्ट्स ऑफ दिस टाइप्स ऑफ वेक्टर्स. क्या क्वेश्चन में जैसे बोल रखा है, इन दिस पर्टिकुलर क्वेश्चन इट इज सेड दैट देयर इज अ quadrilateral, okay, there is a quadrilateral a b c d in such fashion, okay, a b c and d is given over here such that, okay, in such fashion such that E and F are basically midpoints of the diagonal AC and BD. So if I draw the diagonal AC over here, and if I draw the diagonal BD over here, I get the midpoint of BD is basically F and midpoint of AC is basically equal to E. So from here I have to actually calculate this particular result, that is AB vector minus BC vector plus of AD vector minus of DC vector some times of FE vector. So if I complete this FE vector from here, okay, if I complete this FE vector from here, okay, I can complete. Now what results are asked? There is AB vector, this is BC vector, this is AD vector and this is DC vector. So if I say, if I, for example, let me take position vector of vertices as like the position vector of A will be taken as A vector. So for example, if there is an origin anywhere in this particular space or in this plane, then I can assume that vector A has a position vector as A. Now the choice of the origin is basically upon to me. मैं reference कहाँ ले रहा हूँ, that is upon to me. So I can take in the such fashion that the vector A is basically has a position vector of A, and similarly vector B has position vector B, and vector C, this particular point C has the position vector C, and this particular point has position vector D. So from here, if I look at this particular question that is asked, that is basically, so from here if I compute this first result, that is AB vector minus of BC vector, what will you say from here? So AB vector is basically equal to B vector minus of A vector, okay, minus of BC vector will be basically equal to C vector minus of B vector. So from here if you compute the result, you will get basically equal to 2 times of B vector minus of AC vector A vector plus C vector का minus, ठीक है. I hope this particular result is clear. Now similarly if you compute the other result, that is AD vector minus of DC vector, what result will you get from here? So from here you will get the result as D vector minus of A vector minus of C vector, because final position पहले आता है then the initial position. So from here you will get the C vector minus of D vector. Now this particular question actually revised all the important concept of position vector, addition, as well as the midpoint theorem, that is on the section formula. So from here you will get the result as something as 2 times of D vector minus of A vector plus C vector. So if I add this both the result, that is what is asked in the question, that is A vector minus of BC vector, so plus of AD vector minus of DC vector. So if I compute this particular result, what will I get? I will get 2 times of B vector plus D vector minus of 2 times of A vector plus C vector. Now what can you say regarding the midpoint? So if I talk about midpoints E and F, what can you say? Now the position vector of the midpoint E and F can be given as, so if I say the position vector of point E is basically E vector, then I can write this E vector as A vector plus C vector divided by 2 by the midpoint formula, what we studied in the section formula. Similarly the vector, if the point F has a position vector F vector, this can be written as B vector plus D vector divided by 2. Okay, so from here if I compute this result in this particular fashion of E vector and F vector to get this result of FE vector, then I can write this particular thing as 4 times of BD vector plus D vector B plus D vector divided by 2 minus of 4 times of A vector plus C vector divided by 2. So from here I will get the result as 4 times of F vector minus E vector. But what is asked in the question? The question is asked in terms of EF vector or FE vector. The question is actually asked in terms of FE vector. So if it is asked in terms of FE vector, then I should have the E and the in this particular position in the final position should be subtracted from the initial. So in this particular situation I can also write this as minus 4 times of E vector minus of F vector. So from here I will get the result which is basically equal to minus 4 times of FE vector, which is actually asked in the question. So from here the value of the scalar value is basically equal to minus of 4. ठीक है, अब ये माइनस जो साइन मैंने यहाँ पर समझाया था ना, जो इंपॉर्टेंट, जो लास्ट डे में मैंने जब माइनस वाला साइन समझाया, इस पर्टिकुलर पॉइंट में मैक्सिमम नंबर ऑफ स्टूडेंट गलती करके आएंगे. ठीक है, सो आई होप दिस पर्टिकुलर मिस्टेक यू वोंट बी डूइंग इन द कैलकुलेशन पार्ट. काफ़ी इंपॉर्टेंस देके कैलकुलेशन करना, कभी शांत होकर कैलकुलेशन करना, हैव सम पेशेंस एंड सॉल्व दिस पर्टिकुलर क्वेश्चन, क्योंकि ये भी 4 नंबर क्वेश्चन है एंड इट विल डेफिनेटली गिव यू एन ईजी का मार्क्स. ठीक है, तो ऐसा टाइप का क्वेश्चन भी जेईई मेंस में आ रखा है. ठीक है, सो आई होप दिस पर्टिकुलर क्वेश्चन इज क्लियर एंड विद दिस लेट अस स्टार्ट द टुडेस टॉपिक, दैट इज बेसिकली वेक्टर प्रोडक्ट. So vector product also known as a cross product. Now why it is known as cross product? Because it is actually the direction of this basically is given by the cross result of them, and the symbol, for example, and the symbol is basically the cross over here. Unlike the dot product, we use a symbol dot over there, a symbol is the cross symbol is actually used over here. So how it is basically vector product or cross product is defined. For example, we have a vector A vector and B vector are actually given vectors, okay, and they are non-zero, non-parallel, non-linear vectors, non-collinear vectors, okay. Now if I have two vectors A vector and B vector which are non-zero, non-parallel and non-collinear, then I can define this particular vector product as A cross B. A cross B vector is basically equal to modulus of A into, that is multiplied by modulus of B times the sine of theta, if the theta is the angle between the two vectors, okay. Theta is basically the angle between two vectors. I hope this particular angle between two vectors actually concept is clear. Now how to take the angle? Basically you have to join both the tails or both the head and take the angle which is basically less than 180 degree, okay, and this particular gives the modulus value or the magnitude value of this particular vector result times the unit vector which is basically perpendicular to both the vector. So this particular thing actually gives the magnitude of A vector cross B vector, because unlike the scalar product which gives the when two vectors are multiplied in such a fashion that the fashion is basically dot product, in that the result is basically a scalar value. Similarly, if you multiply two vectors in such a fashion that we perform a cross product, then the result we get is basically a vector. So the result over here we get is basically a vector result. So result is basically a vector, okay. The result which you get is basically a vector result. So from here this particular gives the magnitude of the vector, and this particular unit vector actually gives the direction of this particular vector. Now the direction plays a very important role. Now how to calculate the direction? Now similarly you in the properties, while I will go on the properties, unlike the scalar product which is basically commutative in nature, the vector product is not commutative in nature because of the direction. The magnitude will be same but the direction won't be same. So I will explain the direction in very nice detail, okay. So if I have this vector A in this particular fashion and vector B in this particular fashion such that both of the vectors are lying in the same plane, or with the two vectors we can form any plane in which the two vectors actually lies, okay. So two vectors are obviously coplanar vectors. I already talked about this particular property. So if I have this angle between the two vectors is basically equal to theta, then if we perform the cross product, how to take the direction of cross product? Now the cross product direction is basically given out by the right hand rule. So how to take the right hand rule? So what will you do? Basically if I have to perform the A cross B, so you have to take care of what is the initial value, that is basically you have to perform initially is as A and finally you have to go to B vector. So the cross rule and this particular direction is also taken out by the rule known as right hand rule or the screw rule, okay. Many types of that, but what I would prefer is basically right hand rule, and this particular right hand rule will come very handy when you will solve questions of EMF in your concept study of class 12 physics, okay. So let me talk about how to take the cross product. So for example, the initial is basically vector A. So what you will do, you will take the palm of your hand, and place it in the direction of A vector. You will take the palm of your hand, that is basically the open face of this hand, and you will place it in terms of A vector. You will place this particular palm of your hand in the A vector direction, and you see over here you will get the B vector. You will get to the B vector when you curl your palm across this particular fashion. If you curl your palm across anti-clockwise fashion, then you will get get to the B vector, and in doing so the thumb actually points to the direction which is basically the direction of the n cap. In doing so, the direction of the thumb basically gives the result of the n cap. Now एक बात मैं फिर से बता रहा हूँ, ठीक है, टेकिंग द डायरेक्शन काफ़ी बच्चे गलत कर देते हैं, ठीक है। डायरेक्शन लेने के मैंने बोला था राइट हैंड रूल, काफ़ी बच्चे लेफ्ट से रूल निकालने चालू कर देते हैं, ठीक है। सो दैट इज टोटली रॉन्ग एक्चुअली। इफ यू वांट टू अप्लाई द राइट हैंड रूल से आप अप्लाई करोगे देन ओनली विद दिस पर्टिकुलर सिमेट्री प्रोडक्ट विल कम, ठीक है, काम करने वाला है, ठीक है। So I hope this particular result is clear. So in doing so, the thumb actually points in the direction which is basically perpendicular to this, and this particular vector which is perpendicular to B vector, which is perpendicular to A vector, and this is not in the plane of this A B vector, then such vector is basically the result which is known as A cross B vector. A vector cross B vector. Now this particular vector is actually known as A vector cross B vector. I hope this particular result is clear. And from here, if you see an important thing that you get from here, you will see that A cross B vector is basically perpendicular to B vector as well as it is also perpendicular to A vector. So in the many times in the question you will be asked to calculate a vector, calculate करके दिखाओ in that particular direction which is perpendicular to A vector and B vector. In that particular scenario you will always calculate the unit vector along the A cross B vector. I hope this particular result is clear. Okay, so with this let us move on to important note. So first note that I want to talk about, okay, so if I say if any one of A vector or B vector is basically equal to null vector, then the result of A cross B vector will be how much? Will be equal to 0 because the modulus value will be 0, but I cannot say this is equal to 0 because 0 is a scalar value and it should be equal to null vector. I hope this particular thing is clear. And in this case, if the vector is null vector, then it had infinitely many directions. In that particular scenario, we cannot define the direction which is perpendicular to both the vectors. That's why when I was talking about cross product, I clearly mentioned that two non-zero vectors, non-parallel and non-collinear vectors should be there. So if these particular things are there, then only the result will give a vector which is perpendicular to both the vectors. Then only it will generate a result which is perpendicular to both the vectors. So similarly, if we have in this particular case, if we have A vector or B vector, any one of them as null vector, then the result is null vector. So again, if A vector and B vector are collinear vector, now this will be a test for collinearity. Two vectors दे रखा होगा, अगर टेस्ट करने बोला these two vectors are collinear, in that particular test you have to perform the cross product and equate it to the 0, equate it to null vector. That is a test for collinearity. Similarly, if there are two collinear vectors, then the result will be basically the cross product result will be equal to 0 or null vector. Okay, is basically equal to null vector. So I hope this particular result is clear. So whenever you are given with a question that you have to calculate a vector in the direction perpendicular both the vectors, then you have to make sure that both the vectors are like non-collinear vector, or both of them are non-parallel vector, or both of them are non-zero vector. In that particular fashion you can take the cross product and go on solve your question. Similarly, if A vector is basically parallel to B vector, then also the result of A cross B vector is basically equal to null vector, because over here sin theta is basically equal to 0 as theta is basically equal to 0 degree. So theta is 0 degree, because if we have two parallel vector in this such fashion, then what will be the angle between two vector? The angle between the two vector will basically equal to 0 or 180 degree. Any one of them you can say. 180 degree whenever they will be anti-parallel to each other, and 0 degree whenever they will be in the like direction, okay, in the same direction. Okay, so from here if you put the sin theta value, you will also get 0. So with this the result will be also a null vector. I hope this particular concept is clear. Now with this let me try and solve an example. So this particular question actually came up in the AIEEE examination of 2007. Okay, now this question is a good question. So in this question it is said that there are two vectors u vector and v vector such that both of them are unit vectors, okay, and theta is basically an acute angle. Acute angle मतलब पता है ना, जो angle which is less than 90 degree. So acute angle between these two vectors, okay, acute angle between these two vectors, okay, acute angle matlab less than 90 degree. So then you have to say and comment upon this particular vector product, 2 times of u cross 3 times of v. So from here you can see this 2 and 3 are basically scalar results, so you can directly take this thing as common and you can write it 6 times of u cross v vector. So from here what can you write? You can write this particular thing as u vector ka modulus times of v vector ka modulus times of sin of theta, and whole into this particular direction will be given as by n unit vector. So n unit vector basically represent the vector which is perpendicular to both the vectors, that is u and v. So from here if I compute and say that the result, and it is also mentioned in the question that the result of 2u vector cross 3v vector is basically equal to another unit vector, is also resulting in unit vector. So in that particular scenario you have to comment on the value of theta. So theta का कितना values possible हो सकता है, you have to comment on this particular thing. So if it is said that 2u vector cross 3v vector is basically unit vector, what you can do, you can take this, because unit vector that means it has unit modulus. So from here if I take the modulus and equate it to 1, and then what is basically the modulus value of this particular vector product? This basically vector product modulus is basically 6 into the, what is u ka modulus? It is 1, v ka modulus is 1, so 6 into sin theta is basically equal to 1. So from here sin theta ka value kitna aega? From here sin theta value is basically 1 by 6, and how many possible values of sin theta can be possible? So because theta is actually less than pi by 2 and obviously greater than 0, so from here the theta का जो possible value that is only one value, that is basically an exact unique value, one unique value. So from here the number of possible values of theta will basically be equal to 1, so only one possible values of theta will be possible. I hope this particular example is clear. Okay, so with this let us move on to study about the properties of vector product. Now before starting about the properties of vector product, let me talk about the geometrical importance of what is the application of vector product. Now the geometrical importance is basically the direction that is basically used to calculate, but without the geometrical importance there is also an importance that is basically geometrical interpretation of vector product. That is basically if you have a vector such that a vector as this particular fashion and b vector as this particular fashion, such that the angle between the two vectors is basically equal to theta, and if you compute the cross product, then you will get the vector which is perpendicular to both the vector. Okay, now what is basically meant, and if I compute a triangle, if I complete this particular parallelogram, in such fashion that let us name this vertex as OA, B, and this is C, and in this parallelogram OABC, if I take a perpendicular drop on the line OA, then on the line OA and label it as AL. Okay, so from here in the triangle, so from here if I take the triangle OC and L, if I take this particular triangle OC and L, and if I apply the because I want to know what does the magnitude of a vector product implies. So for doing so I need to know what is the sin theta is actually implying. So from this particular triangle, if I have to find out the sin theta value, what will you say? Sin theta is basically perpendicular, that is CL, divided by the hypotenuse, that is OC. And now if I say that basically this is a vector, this basically vector is a vector, and this is basically b vector. So if I compute this a vector cross b vector, and then if you say what is the result, you will say the result is basically modulus of a multiplied by modulus of b times of sin of theta and into dot product with the unit vector which is basically perpendicular direction, and this basically is the direction, but I am not actually worried about the direction. I am interested to know what is that the magnitude of this particular vector product implies. So from here if I see the magnitude, what will this magnitude implies? So from here if I say what is the magnitude of A, you will say that is basically equal to OA, and similarly what is the magnitude of B vector, that is basically equal to OC, basically equal to OC, not a vector. Okay, if I am talking about only magnitude, so I won't be representing in times of vector, it is basically OC OC length, and into sin theta, if I compute sin theta, this is basically CL divided by OC. So from here if I cancel OC and OC, then I will get the result as OA into CL. Now what this particular result implies, this is basically the base into height of the parallelogram from that particular base. This is basically base into height of the parallelogram from the particular base times of n unit cap. And if you see this particular result, this result is nothing but what is known as the area of parallelogram. OABC. So from here you will get the result, basically the magnitude of a cross product actually implies the area of a parallelogram. I hope this particular thing is clear. So with this you can directly define this particular relation, that if you are given to find the area of a parallelogram and such that the two corresponding sides of a parallelogram are given, you will have to directly compute this result of for example the two corresponding sides of OA vector, and have to compute the cross product with the another corresponding, that is OC vector, and you have to find the magnitude value of this. So with this you will directly get to the result of what is known as the area of a parallelogram. So if you have to find the area of a parallelogram, you can do in this particular fashion. Okay, so I hope this particular thing is clear. And also if you actually have to find out the if you compute this, if you calculate this in terms of triangle. Okay, if you form a triangle inside this particular parallelogram such that this triangle divides the parallelogram into two equal halves, and in this particular situation also, if you have to calculate the area of the triangle OAC, and if this triangle divides this parallelogram into two equal halves, we know by the properties of triangle that we actually studied in class 9, we saw that a triangle in a parallelogram basically along the diagonal actually divides the parallelogram into two halves. So from here you will get to the value of this as the to as this particular area. So if I compute 2 times of this area of this triangle is equal to area of parallelogram. So from here you can directly get the result of the area of this triangle OAC will be equal to half of the area of this parallelogram, that is a modulus of OC vector cross OA vector, and the modulus. See, since the modulus is given over here, I am not worried about the direction. So I can take the both the vectors in any of the order. Okay, I can take the vectors in any order. I can take the vectors in any order and compute the cross product, and then have to calculate the magnitude. Okay, so I hope this particular result can also be written as half times of OA vector cross OC vector का modulus, because we are only concerned on modulus, and the modulus value of a cross product is the same for both these things. For example, if you compute the magnitude of the A cross B vector, which is basically same as the modulus of B cross A vector, but both the vectors which are actually computed from this particular product is not the same value. Okay, I hope this particular discussion is clear, and with this let us move on to the study of properties. And the very first property that basically we study about is basically the first property, that is known as a commutative property, that doesn't hold for this vector product, that is A vector dot B vector is basically not equal to B vector dot A vector. So from this can be seen from here in this particular example. So if you see this A vector cross B vector, then you will get a result, and the thumb will be pointing to the upward fashion. So if I say that A vector and B vector is lying in the xy plane, then the A cross B will be lying in the y axis, will be the vector which lies in the y axis. Similarly, if I compute B cross A, such that you will put B in the direction, you will put the thumb of your, the palm of your hand in the direction of B, and you will curl your hands in the direction of A. In that particular situation, the thumb will point in the downward direction. In such situation, you will get the direction of this particular B cross A, which is in the minus the z axis, which will be in the downward direction. I hope this particular result is clear. So from here you will say that both of the vectors are not equal, although their magnitude value are equal, but both of the vectors are not equal, and in such that they are not commutative in nature, and hence they are not commutative in nature. They are not non-commutative in nature. Okay, they are not commutative in nature. I hope this particular result is clear. Okay, with this let us move on to the second property, and second is another important property, that is basically if you have basically a scalar value, and if you take a scalar value of my A with cross product with another scalar value of B, this can be written as Mn times of A cross B. Okay, I hope this particular result is clear, and it also can be written as A cross B times of Mn, because this is basically a scalar value. So scalar obviously follows the properties of the algebra, that is basically commutative properties can be followed. So this doesn't matter how you actually multiply, because this is a scalar which is multiplied to a vector. This is a scalar which is multiplied to a vector. It doesn't matter, but what matters is basically the order in which the vectors are multiplied for the scalar, for the cross product. Okay, I hope this particular result is clear. Okay, so let us move on to the third property. The third property basically talks about, the distributive law. Okay, so if I have three vectors, A vector, B vector and C vector, in such fashion that if I compute this particular result, A vector plus B vector C vector can also be written as A cross B vector plus of A cross C vector. The only thing that you must take in mind, that is basically the order in which it is multiplied. यहाँ पर देख रहे हैं कि पहले A से B को multiply करें, that means we have to write A at first. So A is written first. Similarly, A को C से जब cross product कर रहे हैं, the A is written first. So obviously you have to write A as first. Similarly, if you compute this particular result, B vector plus C vector cross of A vector, in that particular case you will get this result as B cross A plus C cross A. Okay, so I hope this particular notation will be taken care of, and this actually shows the distributive property. Okay, so with this let us move on to the another important properties. Okay, is basically two parallel vectors are given, then their cross product is basically equal to 0 vector or null vector. Okay, so similarly if you compute the cross product of I cross I and similarly J cross J, similarly if you compute the product of K cross K, you will get the result which is equal to null vector. And similarly for remembering the result of I cross J, okay, J cross K okay, and k cross I, you have to directly draw this particular circle in such a fashion that is I, j and k are written in this particular fashion, and these particular arrows are given like this way. Okay, now from here if you compute this particular circle and if you write I over here, j over here and k over here in this particular fashion such that I cross j, I से जब j जा रहे तो what is the result? You will write directly over here, it is k cap. Similarly j से जब k जा रहे, now the direction will be positive if you take the direction as anti-clockwise. So anti-clockwise direction is taken as positive. Anti-clockwise direction is taken as positive. If you take the direction as clockwise direction, then you will get the result as negative. So similarly, if you compute j cross k, you will get the value as I cap. Similarly, k cross I will basically be equal to j cap. And similarly, if you compute I cross k, what the result will you get? Because I cross j, you are moving in a clockwise fashion, so you will put a negative, then it is basically minus of j cap. I hope this particular result is clear. Okay, so with this, another important way to calculate, to compute the basically the vector product is basically through the use of determinants. So here you will see the application of determinant. For example, we have a vector a1 I cap, a2 j cap plus a3 k cap, and b vector is actually represented as b1 I cap plus b2 j cap plus b3 k cap. If you have to compute the a cross b vector, then you will directly calculate the value of this determinant, that is you will put I, j and k over here, and the I component of a will be written over here. Similarly, I component of b will be written over here. Similarly, j component of a and j component of b, k component of a and k component of b, and if you compute this result of the determinant value, then you will get the vector which is directly the result of a cross b vector. I hope this particular result is clear. Okay, now let us move on to study about another important result, that is basically whenever you will be asked in the question to calculate a vector which is perpendicular to both the vectors, then you will directly go for example, there is a vector and b vector which lies in one plane, and you have to find c vector. You have to find c vector such that this c vector is perpendicular to a vector and c vector is also perpendicular to b vector. In that particular fashion, you will directly assume c vector as some lambda times of a vector cross b vector divided by modulus of a vector cross b vector. I hope this particular thing is clear. Divided by modulus of a vector times of b vector. So from here you will get the result of c vector, and if the direction of c vector is mentioned, then you can, if it is not mentioned, then you can easily use, because if it is said that it is in a perpendicular direction, but in which particular fashion, is it above the plane or it is below the plane, if it is nothing is mentioned, you will directly put plus minus result over here. You will put the plus minus thing over here, and then you will compute this particular result. Okay, I hope this particular thing is clear. With this, let us move on to the another important property, that is basically about the area of a parallelogram, area of a triangle. Okay, so what we actually saw about calculation of area of a triangle, that is basically multiplying the corresponding side. Okay, we cross product with the corresponding side of the vectors. So if this is OA vector and OB vector and given, and such that the angle between them are theta, then you have to, if you have to find the area of this particular triangle OAB, then you will do this half times of modulus of OA vector cross OB vector, इनका magnitude आप देके बोलोगे. But this particular thing can also be expanded if you expand, and if I say you that the position vector of O is given as A vector, the position vector of B is A is given as B vector, and similarly the position vector of B is given as C vector. If the position vector is mentioned, instead of sides, if the position vector is mentioned instead of side, then you will directly, if you solve this particular, you can also directly go on and form this vector OA vector. Similarly OB vector, you can form this vectors if the position vectors are given such that OA vector basically will be B vector minus A vector. Similarly OB vector will be basically C vector minus A vector. But if you compute this particular result, that is B vector minus of A vector cross C vector minus of A vector, and if you compute this particular result of this magnitude, you will directly get to the result. What is the result? Is actually half times of A cross B. Okay, half times of modulus of A cross B plus B cross C plus C cross A. in such a fashion that you see that there is a chain over here. So if you see the chain over here, you will directly remember the result. So in case the vertices of a triangle are actually given in this particular fashion, you can directly get to the result of what is the result of the area of a triangle. Similar to this result of area of a triangle, there is also a result of important result, that is basically the length of the perpendicular from over here, the length of the perpendicular, okay, on this particular OA line. So if I say the length of the perpendicular on this OA line, what if this is represented as BM, if the length of the perpendicular from on the OA line from the vertex B is basically BM, what can you say? So from here you can actually see that this particular area can also be written as terms of half times of the base is basically OA vector ka modulus, means magnitude, times of this particular length, and if this particular length is actually represented as L, so because I have to find, this is not the cross product, this is basically actually algebraic multiplication, okay. So I won't use this particular symbol so that you don't get confused. Okay, so from here basically this is the length of the perpendicular, but now I want the length of the perpendicular. So what can you do? You can equate this both the results, and from here if I say what is the length of the perpendicular, that is BM, you will say that this is basically equal to A cross B plus B cross C plus C cross A modulus divided by modulus of OA. And what will be the modulus of OA? That basically will be B vector minus A vector ka modulus. Okay, so I will say you an important trick to how to remember this particular formula. मान लो आपको perpendicular drop करना है O से on the line AB, and you have to find this result of this length, that is basically D. In that particular fashion जो numerator वाला term है वो तो constant है, बट डिवाइड किससे करना है? डिवाइड उसी क्वांटिटी से करना है, उसी क्वांटिटी का मैग्नीट्यूड से करना है जिसके ऊपर आप परपेंडिकुलर ड्रॉप कर रहे हो. फॉर एग्जांपल फ्रॉम द पॉइंट O you are dropping a perpendicular on the line AB. So if this is point 10, and if you are dropping this perpendicular on line AB, then you will take the vector of the line AB. In that particular scenario you will divide with the modulus of C vector minus B vector, that is the modulus of the line AB. आई होप दिस पर्टिकुलर रिजल्ट इज क्लियर. ठीक है, आप ऐसे ही याद करो, जिसके ऊपर प्रोजेक्शन मतलब जिसके ऊपर परपेंडिकुलर ड्रॉप फेंक रहे हो, जिस लाइन के ऊपर ड्रॉप हो रहा है, तो उसी का मॉड्यूलस मैग्नीट्यूड से डिवाइड करना है, आई होप दिस पर्टिकुलर रिजल्ट इज क्लियर. ओके, सो विद दिस लेट अस मूव ऑन टू द another important property. Okay, another important property, that is basically sometimes in the question of area parallelogram there will be diagonal will be mentioned. ठीक है, अब जब एरिया पैरेललोग्राम में अगर दो कॉरस्पॉन्डिंग साइड दे रखा है, अगर आप पूछा जाए कि व्हाट विल बी द एरिया ऑफ द पैरेललोग्राम, यू विल डायरेक्टली से द रिजल्ट दैट बेसिकली वेक्टर प्रोडक्ट कर लो दोनों साइड का, कॉरस्पॉन्डिंग साइड का, एंड कैलकुलेट द मैग्नीट्यूड हेलो. बट इन सम सिचुएशन दे विल बी गिवन विद द डायगोनल वेक्टर्स. ओके, they will give you with the diagonal vectors in such fashion that this particular diagonal, for example this is A, B, C and D over here, this particular diagonal is represented D1 vector and this particular diagonal is given as D2 vector. So from here if you have to calculate the area of parallelogram A, B and CD, you will directly do this particular result, that is half times of modulus of D1 vector cross D2 vector. Now this particular result looks similar to that of the area of triangle, but don't get confused with this particular result. जब बोला जाए कि दो corresponding side दे रखा है, then you will directly compute the scalar dot cross product and you will calculate the magnitude. Now if the question says that there are diagonals are given in such fashion, then you will take half times the magnitude value of the diagonal cross product. I hope this particular result is clear and you will definitely remember this result. Okay, ये काफ़ी ज़्यादा important type का result है. ठीक है, इन द क्वेश्चन भी काफ़ी ज़्यादा जगह में यूज केस में आने वाला है. ठीक है, सो विद दिस लेट अस मूव ऑन टू द सेवेंथ प्रॉपर्टी, दैट इज ऑल्सो नोन एज द लैग्रेंजेस आइडेंटिटी. लैग्रेंजेस, ओके, लैग्रेंज, आई रोट द स्पेलिंग मिस्टेक. नाउ विद दिस आई विल टॉक अबाउट लैग्रेंजेस identity. Okay, so what does Lagrange's identity talks about? So this is basically nothing but it actually relates the modulus value of A vector cross B vector का whole square will be basically equal to modulus of A modulus of B whole square, modulus of A का whole square, modulus of B का whole square, and you multiply then subtract this particular result, that is A dot B इसका whole square. And this particular thing can also be written in this fashion, that is A vector over here and B vector over here, and over here if you have A vector and over here you have this particular result can also be written as like So from here you can see this basically modulus of a vector ka whole square times of whole square, and over here this will be basically the result, and this result will over here will be modulus of a ka whole square, and this particular result will be a dot b. Similarly, this particular result will be a dot b over here, and if you compute this 2 cross 2 matrix ka determinant, then you will get this result of what is the modulus of a cross b ka whole square, and this particular identity actually known as the Lagrange's identity. Okay, then this is a very simple identity, and you will see that there will be many use cases of this particular identity in the questions. Okay, so if I will take up questions, I will actually show you what is the actually the importance of this particular identity. Now, when I will be talking about the previous year questions. Okay, so with this, let us move on to the another important, that is basically the application part of the. Okay, so with this, let us move on and solve out some example. Okay, example question regarding it. So there is a important question that actually came up in IIT question paper of 2007. Okay, of 2007. Now this particular question was basically an interesting question, and it says that a vector, b vector, and c vector are basically three unit vectors. Okay, they are given that a vector, b vector, and c vector are three unit vectors such that the summation of these three vectors, a vector plus b vector plus c vector, is basically equal to null vector. In that particular situation, you are given out with some options that you basically have to compute. The option says basically the computation of a cross b plus b cross a plus c cross a. Now you have to comment on this particular result, okay, of a cross b, b cross c, and c cross a. Now what can you comment on this particular result? Let us check from the question. So from the question, what is given is basically that a vector, b vector, and c vector are basically three unit vectors such that the summation of these vectors is basically equal to null vector. Now when is the summation of these three vectors is basically null vector? If they represent the side of a triangle in this particular fashion, this is a vector, this is b vector, and this c vector, this basically sides of a triangle. And if the triangle are basically of the equal length, then I can say this particular triangle is basically a equilateral triangle. In that particular scenario, all the angle in between is basically 60 degree. So from here, if I say what is the angle that is between a vector and b vector, you will directly say me that this is 120 degree. ओके गलत मत कर देना, 60 मत कर देना, ठीक है. अब देखो क्वेश्चन में कि ए वेक्टर इज गिवन इन दिस फैशन एंड बी वेक्टर इज गिवन इन दिस पर्टिकुलर फैशन. Now what you have to actually do to take the angle, you have to extend this a vector in this particular fashion. You have to move this a vector in this particular place such that both the tails coincide or both of their head coincide, and in doing so you will take the angle which is basically less than 180 degree, and that is a theta, that is basically 120 degree. So I hope this particular angle between two vectors is clear. So from here, if you compute the angle in this particular fashion and you get the result as 120 degree, the angle between two vectors. Okay. So from here, what you can go and solve is basically from this particular result, if I take the cross product on this result on both the side, if I take a cross this particular equation which is given, that is a plus b plus c vector is basically equal to 0. If I take cross product with this, then I will get a cross null vector which is basically equal to again null vector. And if I compute this particular cross product, what I will see, if we compute this cross product of a cross a, that is basically equal to 0, because a cross a will be the same vector, and the theta will be 0, so theta will be 0, sin theta will be 0, so similarly the result will be 0, that is null vector. Now a cross b, from here a cross b plus a cross c, which is equal to null vector. Now similarly, if you go on and compute this b cross this particular result, and then also you will get the result something as b cross a plus b cross c, which is equal to null vector. And similarly, if you compute the c, then you will get the result as c cross a plus c cross b. So from here, if you add all the three equations, if you divide equation 2, this is the equation 3. So from here, if you add all the three equations, what you see that this particular thing is basically the negative of this particular result. Okay, this vector is basically negative of this particular vector. Similarly, a cross c is basically negation of c cross a. So and b cross c is basically negation of c cross a. So from here, if we add all these results, what result I will get, that is basically a cross b plus b cross c plus c cross a, and iska 2 times basically is equal to 0 vector. If I add all these results, I will get the value which is basically 0 vector. So from here, what can I comment on? What can I comment? I can directly comment that these particular results are basically equal, but they are equal in their magnitude, but not in the direction. Okay. Okay, so these results basically are equal, but not in their they are equal in their magnitude, but not in the direction. So from here you can compute this. You can go on and compute these results. Okay, you can go on and compute the results, and you can directly say me. You can directly say this from equation number 1. You can also say that A cross B vector is basically equal to C cross A vector, and similarly C cross A vector can also be said as B cross A vector, B cross C vector from equation number 3. So from here we get the equality relation B cross C vector. So from here we get the equality relation, and such that all of the summation are equal to 0, because if we take all the sums, they are cancelling out and equal. The result which is giving it is basically null vector, and we see that basically the individual components are basically equal. That is A cross B is equal to C cross A is basically equal to B cross A, but they are not are equal to a null vector. They are all individually equal, but they are not individually equal to null vector. Okay. So I hope this particular result is clear, and from here the option that was actually given out is basically both of their basically the individual values are equal, but they are not equal to null vector. Now this is very important thing. Why it is not equal to null vector? Because the magnitude of this vector is basically some quantity, that is the magnitude of, if I calculate the magnitude of A cross B, if I calculate the magnitude of A cross B, this is basically equal to 1 into 1 into sine of 120, and sine of 120 is basically equal to root 3 by 2. Okay, so from here you will actually get the value which is not equal to 0. So you cannot directly say that A cross B is basically a null vector, because they will be equal vectors, but not this vector will be equal to this vector, will be equal to this vector, but not equal to null vector, but will not equal to null vector. So this was the question that was actually asked in the IIT 2007 paper. Okay, I hope this particular question is clear. Now with this, let us move on to study about some applications. Okay, applications of vector product. Now what are the applications of vector product? Now basically the applications of vector product, what we will see in mathematics basically in the planes, but apart from the planes, the application of vector product is basically in the computation of physical quantities in physics. That results of the physics is basically the moment of force. The first important result that we actually have to calculate is basically moment of force. Okay, so you know that how a moment of force is basically calculated. So for example, there is a force which acts at a point O, and the force is acting along this particular fashion, this particular line, and this force value is basically F. Okay, the value of this force is F, and it is actually acting along this on this particular point. Let me represent the point as A and B. Okay, so if this particular point is A and this particular point is B, because the force vector is basically acting along the line AB, and there is a hinge over here, and there is a rod which is attached to this particular hinge in such a fashion that the point A of this rod is actually exposed to the force in this particular direction. Now if I have to say what is basically the moment of this particular force, the moment of this force about the point O, then what you will say, then you will directly say that what is the moment of this force about the point A, that what is the turning effect of this particular force about the point A. You will actually compute the result which is known as the moment of force, and you will have to compute basically the vector product. So from here, if I say this AB vector is basically F vector and the OR vector as a position vector of point A as R vector, then the value of the moment of force is basically R cross F. So you have to find the value of R cross F in order to get to the moment of force. I hope this particular result is clear. Now many situation you have to actually find the magnitude of moment of force. So in that particular situation you have to directly find the magnitude of R cross F. Now in many situations you always obviously may be asked that a moment of force along any particular direction. So if I say the moment of force along a line, okay, along a line, and that line has basically a vector basically A. So this is basically the projection of, this is basically equal to the projection of R cross F vector on this particular line vector, that is A vector, and this particular result can also be calculated as R cross F का जो वेक्टर आ रहा है उसका डॉट प्रोडक्ट लो किसके साथ, A वेक्टर के साथ, और डिवाइड कर दो किसके साथ, मॉडुलस ऑफ A के साथ. So with this you will get to the result that is basically the result which is known as the moment of force along any particular line. I hope this particular concept is clear. Now let us take up another important case that is actually you will see in physics, that is basically the moment of couple. Now what is couple? Couple is basically when two equal and opposite forces two equal and opposite forces acts on a particular body such that they produce a turning effect of the body, then that particular force effect is actually known as couple effect. So if I have a body, if I have a random body like this, and there are 2 points in the body such that the point is experiencing a force which is in the direction f vector, and similarly the point, this is point A and this is point B, and the point B is experiencing an equal and opposite direction, the equal force but in the opposite direction, is basically point A. So if I compute with respect to center of mass of this particular body will actually perform some rotational motion. So with respect to the center of mass, this particular body will perform a rotational motion. Now if you see the rotational motion, and if I want to know what is the moment of couple, what you will basically do, you will take the distance between these two parallel forces, if I have to actually find the moment of couple, the magnitude of the moment of couple, what you will do, you will find the distance between the two parallel forces. If it is given as d, then you will take this t, and you will multiply with the magnitude of this particular force. You will take the value of d and you will multiply with the magnitude of force. This is basically not vector cross product, it is basically simple algebraic multiplication. Okay, I hope this particular concept is clear. Okay, now this particular concept is a very important concept. Okay, now when you actually talks about rotational motion, used in rotational motion. So I hope I was able to give the real application of this particular moment of force. Okay, rotational motion in physics, in class 11 physics. Okay, you will actually study this in class 11 physics. Okay, now another important thing is of the application of basically vector product is basically to find out the right hand coordinate system and left hand coordinate system. So how will you know what is basically if it is a right hand coordinate system or left hand coordinate system? Okay, now in right hand coordinate system, if you compute, so another important result basically about the right hand coordinate system and left hand coordinate system. So if there is a right hand coordinate system, right handed coordinate system, okay, these type of questions are very rare, they do not come in the examination, and but still I am taking up the concept. Okay, basically if you are having three vectors and they are forming basically right handed coordinate system, then what you will go on and do, you will basically compute this particular result. A cross b vector will be equal to b cross c vector, and similarly b cross c vector will be equal to c cross a vector. And if you compute this particular result and you get this equality, then you will say that this particular three vectors actually hold the relation of right handed coordinate systems. Okay, right handed coordinate system. I hope this particular result is clear. So with this I completed the particular topic of vector product. Okay, so let us try and solve out some important question that actually came up in the examination. Now this question is basically I took up from the JEE previous year questions only to illustrate what types of question actually asked. Basically आप डायरेक्टली कोई वेक्टर प्रोडक्ट के क्वेश्चन आप डायरेक्टली एक्सपेक्ट नहीं कर सकते हो, उसके साथ साथ कुछ और कंडीशन देके आपको कंडीशन निकालने के लिए बोला जाएगा. So let us solve this particular question, and this particular question will give you a good idea on how to actually approach a question. So in this question, if you see that there is a vector A, vector B and vector C, and it is said that these particular vectors actually satisfy such that the vector D actually satisfies this particular equation, that is D times of B vector is basically equal to C vector cross B vector, and D times of A vector is basically equal to 24. So from here what can you comment on the result of modulus of D vector ka whole square. So if I have to find an unknown vector such that the two vector equations are given, what will I do? So from here I see that D dot A vector is basically given as a 24. So from here I can write this particular relation as D vector ka modulus times of A vector ka modulus times of cos of theta is basically equal to 24. But this result won't be helping us. Okay, now before solving this particular result, let us solve this particular equation what is given. So if I take D cross B over here minus, if I take this particular result on this particular side, then you will get that C cross B is equal to null vector. So from here if you take this B vector common, such fashion that D vector minus C vector cross with B vector is basically equal to null vector. So if I say that two vectors is basically if I say that two vectors, okay, so from here if you have two vectors such that this is capital A vector and this is capital B vector such that the cross product is basically equal to null vector, what can you comment on this particular vector? You can comment two important things, that is both the vectors can be parallel vector, both of the vectors can any one of the both the vectors can be equal to null vector, or any one of them vectors can be collinear vector. So collinearity has similar fashion with the parallel relation. So might be they can be a null vector, or might there exist a parallel relation. So what can I go on and say? What can I go on and write? Okay, so if I erase this particular result, I hope you are understanding the result. So if I write this particular fashion such that, so from here in the question we see that b vector is a modulus I that is not equal to 0. So similarly b is not a null vector, and similarly if you calculate this d minus c vector, this will also be not a null vector, because if it was null vector, then the result of d dot a would have been 0, be 0. Okay, I hope this particular thing is clear. So from here what can I say? I can say that d minus c is basically parallel to b vector. So if I say d minus c is parallel to b vector, then I can write this d vector as basically as c vector plus of some lambda times of some constant times of b vector. I hope this particular result can be clear, because I write d vector minus c vector, if it is parallel to b vector, that means there exists some collinear relation, that means lambda times of b vector. I can write this particular fashion because they will be linearly dependent, hence I can write a linear relation. So from here if you see the d vector is c vector plus lambda times of b vector, and if I write this that is 2 I cap minus of j cap plus 4 times of k cap plus lambda times of b vector, that is 3 I cap minus 2 j cap plus 7 k cap. So from here if you calculate the result you will get 2 plus 3 lambda I cap. Okay, and again from here you will get j cap times of minus 1 minus 2 lambda plus k cap times of 4 plus 7 lambda, not k, it is lambda. Okay, so from here you will get the result of d vector. Now if you take compute the dot product of d vector with a vector, the result is basically equal to 24. So from here if you compute this result, if you compute the result of dot product and the a is given as 1 I cap plus 4 j cap plus 2 k cap, so from here if you compute, this result will be basically 2 plus 3 lambda plus 4 times of minus 1 minus of 2 lambda plus 2 times of 4 plus 7 lambda, which will basically equal 24. So from here you will get the value of delta as 2 plus 3 delta minus 4 minus of 8 delta plus 2 plus this is really 8 plus 14 times of lambda is basically equal to 24. So from here if you simplify the result you will get basically equal to 2 plus 8 basically 10 minus 4 basically 6, and if you take 6 on this particular side you will get the result as 18, and if you compute the lambda will be basically 3 plus 14 is 17 minus 8 will be basically equal to 9 lambda. 9 lambda is basically 24 minus of 6, the result will be basically 18. So from here the lambda ka jo value aane wala, that is d lambda is equal to 2. So from here you will get the value of d vector ka jo value aane wala hai, from here if you will get the d vector basically is equal to, that value of d vector basically equal to, if lambda is 2 plus 6 basically 8 I cap minus of because lambda is basically 2, that is 5 minus of 5 times of j cap plus this is basically 4 plus 14 basically equal to 18 k cap. So from here if you compute the value of modulus ka whole square, you will get the result as 64 plus 25 plus 324. So from here the result you will get to the question is basically 64 plus 25 basically equal to 89 plus 324 will basically equal to, this is 13 over here, is 413. So from here the right answer to this question will be option number B. I hope you were able to solve this particular question and you understood how I actually manipulated this particular question. So this particular condition was the most important condition that you saw. Okay, this particular condition was giving the most important idea before solving this question. Okay, this particular condition was the most important condition to take the idea. जब भी मैं बताया था, इसलिए मैंने जब नोट लिखा था ना कि हाउ कैन नॉट रिजल्ट ऑफ द क्रॉस प्रोडक्ट बी इक्वल टू 0, देन नल वेक्टर, तो तभी हो सकता है जब दो वेक्टर में से कोई भी एक वेक्टर या फिर दो वेक्टर नल वेक्टर हो जाए, या फिर दोनों वेक्टर में कोई भी दो वेक्टर को पैरेलल हो जाए, पैरेलल या फिर कोलिनियर हो जाए. I hope this particular result is clear. Okay, with this we move on to the next question, and the next question says that in a triangle, and this basically talks about the application of vector product. In a triangle, the sides of the triangle actually given. जब भी sides दे रखा होगा, we will compute the corresponding side का module cross product and get the magnitude to get the area of the triangle. So if I say this is basically A, this B, and this is C. So from here, what I see that basically AB and AC is actually given. Now actually CA actually is given over here. Okay. So if I see this basically the vector, this direction is actually given as, CA. So and CB is given over here. So from here what can I go on and write? It's basically AB vector plus BC vector plus CA vector. Can I write this vector as null vector? So from here if you compute the result of a summation of both all these things, you will get a relation that is basically equal to 2 plus alpha times of I cap plus 4 plus beta times of j cap plus 3 plus gamma plus delta is basically k cap is basically equal to null vector. So from here you will get the value of alpha is basically equal to -2, and the value of beta is basically equal to -4, and the value of gamma plus delta is basically equal to -3. Now in order to solve the question, actually we have this particular result. So in order to solve the question actually talks about CB vector dot CA vector. So for doing so, if you have to compute the dot product of the CA vector dot CB vector, you basically need the values of these unknowns. That is only two unknowns we have to calculate. Now in order to calculate the values of the unknown, let me solve the area of the triangle. So in order to solve the area of a triangle, let me take CA and AB and take the modulus value, because area of triangle is constant. So as far as the area of the triangle is concerned, that is basically the magnitude value, we don't have to worry about the direction. So if I write this area of triangle ABC, I can write this as AB vector cross AC vector. But if this direction is opposite to the AC vector, then can I also do any then will it create any problem? No, because I am only concerned with the magnitude, so the area won't change. So I can write this also as CA vector CA vector and then take the modulus. So if I compute the result of cross product, that is basically from the determinant method, that is basically if I write the I cap component, j cap component and k cap component, so from here I will get the result as, so from here if you compute the result, and the result will be basically, so and the area of a triangle is actually constant, so we have to don't forget to multiply the half over here, and this particular result is basically given as 5 root 6. 5 root 6 is given over here. So if you compute this particular determinant value, the determinant value that you will actually compute over here will basically equal to 2 times of 5 root 6, that is basically 10 root 6. So if you compute the results, okay, 10 root 6 is the modulus, you have to take the modulus also. So similarly, if I compute if I compute this particular vector, then I will get I cap times of delta minus of 9 minus j cap times of minus 2 delta minus of 12 minus 2 delta minus of 12, okay, minus of 12 plus k times of minus 6 minus 8, basically minus 14. So इसका जो मॉडुलस वैल्यू आएगा वो कितना आएगा, दैट इज 10 रूट 6. सो फ्रॉम हियर इफ आई कंप्यूट द मॉडुलस वैल्यू, दैट इज बेसिकली जो वैल्यू जो वेक्टर हमको मिला दैट इज माइनस ऑफ आई कैप, ओके, एंड द वेक्टर दैट इज प्लस ऑफ जे कैप टाइम्स ऑफ 2 डेल्टा माइनस लैम्डा and plus basically minus of 14 k cap minus times of 14 k cap, and इसका जो मॉड्यूलस वैल्यू आएगा इट इज बेसिकली इक्वल 10 रूट 6. सो 10 रूट 6 कैन ऑल्सो बी रिटन एज 100 into 6 under root, that is basically 600 root under 600. So from here if you solve this value, so what we will get over here under root of 1 square plus 2 lambda minus 12, basically not minus, is basically plus over here. We were taking minus common over here, so you will get minus over here, minus plus over here. So similarly this will basically 2 lambda plus 12 ka whole square plus this is basically 14 ka square, that is basically 196 is basically equal to 600 under root. And if you compute this particular equation, then from here you will get 4 times of, if I take 2 common of this, 4 times of lambda plus 6 ka whole square plus 197 is basically equal to 600. So from here if you compute this is basically 4 times of lambda plus 6 ka, sorry not lambda, this is basically delta over here, okay, not delta, okay, not lambda, delta plus 6 ka whole square plus is basically equal to, I hope I am doing everything correct, okay, just check my calculation once, okay, in case you feel that there is any mistake. So if you compute this result, you will get this 600 minus 197, okay, which basically will be equal to 3, and if you take this common over here, then this is basically 0 1 over here and 403. So what we see basically is 403 and it is not divisible by 4. So might be I made some calculation mistake over here. Let me check for the calculation mistake. Okay, basically okay, sorry, I made a calculation mistake over here. This is basically delta over here, so I took it as 8. Okay, that is the most important mistake that I made. Okay, this is not the result that we are calculating. Okay, so I am sorry for the mistake that I make. Okay, because I am going on solving the question on seeing on the screen, so I might do some calculation mistake. Okay, and in case I make some calculation mistake, don't forget to write in the comment section. Okay, and then I will make changes, okay, accordingly. So this is basically delta minus of 9 का whole square. Again let me check, minus of 9, okay, minus of 9 का whole square plus, if I take 2 common then it will be 4 times of delta plus of 6 का whole square plus 14 का whole square, that is 196. So from here the result will be root under 600. So from here if you compute that, this will be delta square plus 81 minus of 18 times of delta plus 4 times of delta square, 4 times of delta square plus 4 into 6 square, that is 36. So basically will be 144 plus 4 into 6, that 24 into 2, that is 42. Delta is basically plus 196 is equal to 600. So from here if you compute, is basically 5 times of delta square plus these values will be 42 delta over here and 18 minus 18 delta. So if you compute 42 minus 18, what is the result? 42 and minus 18, the result is basically 24. So you will get the result as 24 delta plus 81 plus 144 plus 196. If you compute 196 plus 144, the result you will get over here is basically 340. Check me the calculation. See, 340 plus 81 is basically equal to 421. Is basically equal to 421 is equal to 600. So from here if you compute that 5 delta square plus 24 delta, okay, and to take 600 over here, then if you subtract 600 from 421, how much the result will be? 9. And if you take 7, and then you will get 179. So from here the result will be 179, which will be equal to 0. So from here what the result of delta we are getting is basically to the solution of this quadratic equation. Now let me check for this quadratic equation, but instead of solving this particular relation, we can do one more important thing. Such that in order to calculate the area of the triangle ABC, I can also calculate the value of this particular determinant, that is AB cross BC. Now if I compute this particular result of AB cross BC, if I compute the result of AB क्रॉस बी सी का डिटर्मिनेंट का वैल्यू, अगर मान लो इसका जो क्रॉस प्रोडक्ट मैं कैलकुलेट करता हूँ एंड उसका डिटर्मिनेंट एंड इक्वेटिंग इट टू 10 root 6, if I compute this particular thing, then this will basically minus 2 1 and 3, minus 2 1 and 3, and from here alpha is basically minus 2, beta is equal to minus 4, and this will be gamma minus 2 minus 4, and gamma over here, gamma. Okay, gamma over here. Now if I calculate this particular result, and along the what will be the result of the vector? This is basically gamma minus gamma plus 12 minus of j times of is basically a minus 2 gamma, okay, minus of 2 gamma plus 6, okay, plus k cap times of, along the you have to just solve this particular determinant, and determinant we already have studied in our previous lectures, okay. So this will be 8 minus of minus 2, that is plus of 2, and this is basically this इसका जो modulus of value होगा, that is the magnitude of this particular vector, is basically equal to 10 root 6. So from here if you solve, instead of solving this particular results, so from here if you solve this particular value of this magnitude of this vector, that is gamma, not delta, and why I am writing delta every time, that's a very big mistake from my side. This is gamma over here, okay, not delta, okay. So gamma, this is gamma, okay. So from here you will get the result as gamma plus 12 whole square plus this basically will be 2 gamma minus 2 gamma plus 6 ka whole square plus 10 ka whole square, basically equal to 10 root 6. So from here if you simplify the results, this basically will be gamma square plus 4 gamma square, that is basically 5 gamma square, 2 gamma square, that 2 gamma ka whole square, that is basically 4 gamma square, and gamma square over here. So this will be basically 5 gamma square plus 144 plus 36 will basically result in 144 plus 36 is how much? The result is basically 180 and plus 180, and if you compute the second value, you over here you will get 24 gamma, and this will, from here you will get minus 24 gamma, which will cancel out, plus 100, okay. इसका जो taking square of both the side, then also this will be the square of this particular quantity, then I will get 600 over here, and if you compute this particular result, 5 gamma square will basically be equal to 600 minus 280. So from here I will get the result which is 320. So from here the value of gamma, if I gamma square will basically, if I divide by 5, then I will get 64. So from here the value of gamma will basically be equal to 8, and if the value of gamma is 8, then from this particular relation what is the value of delta? So gamma plus delta is basically equal to -3. So if value of gamma is basically 8, then value of delta is basically -5, but in the question it is said that value of delta cannot be negative. So if I use this result as gamma is -8, then I can use delta is +5, then also I will get the result as -3. So from here I get the result to the question that is asked in the question. That is basically if I see the CA vector will basically be equal to 4i cap plus 3j cap plus 5k cap, and similarly if I calculate CB vector, that vectors I will get will basically -2i cap minus 4j cap and plus of gamma, that is minus of 8k cap. Now in order to compute the dot product that is actually asked in the question, then the question it is said you have to actually calculate the value of the dot product. So if I have to calculate the dot product, what will the value will be? So in order to compute the dot product, let us multiply the individual components with minus of 8, this will basically minus of 12, and if you compute this result, okay, this result will be minus of 40. So from here the result will be minus of 60. Okay, so if you compute the result from here, you will get the result as minus of 60. So the options is not given over here. I guess this option basically was meant to be minus of 60, and with this the correct answer to this question would have been option number A. So I hope this particular question was clear. Now this question was basically, जो question मैंने लिया था ना, basically to take an example like how you will actually manipulate the result in the given exam. Now आप देख पा रहे होंगे जब when we are actually solving this particular fashion, जब मैंने पहले इस वे में सॉल्व किया था, like AB this AB vector and CA vector का क्रॉस लेकर मैं कैलकुलेट किया था, then I got a very bad kind of result and I was not able to move forward. But instead of solving this particular result, I just took my change and I took a change in such a fashion that I calculated this result. Okay, instead of solving AB cross CA, I solved this particular result as AB cross CB. Okay, CB is given over here, so I should have written like this. It's actually CB. That's my mistake. Okay, so over here I wrote CB, and then I take the magnitude value of that particular vectors, and when I solved this, I got the value as plus minus of 8, as easily as plus minus of 8, and in that particular fashion I do not have to solve like difficult quadratic equation. It got simplified to this particular quadratic equation. So this is how actually you have to tackle questions in examination. So with this I come to the end of the lecture. I hope today's lecture, the discussion about the properties of vector product is basically clear. Now आज का लेक्चर में मैं काफ़ी इंपॉर्टेंट लेक्चर था, हर एक प्रॉपर्टीज़ को मैंने डिटेल्स में समझाया था, ठीक है. साथ ही साथ मैं ज्योमेट्रिकल इंप्लीमेंटेशन ऑफ व्हाट इज द मेंट बाय द वेक्टर प्रोडक्ट इज बेसिकली ऑल्सो कवर्ड इन दिस टुडेस लेक्चर. आई होप you have understood all the lecture concept, and if you do like this, if you like the particular lecture, then do like this particular video and subscribe to my channel to never miss out in upcoming content. As well as जो मैंने बताया था कि आप लोग को वीडियो चाहिए कि मैथ्स का टिप्स हाउ टू स्टडी मैथमेटिक्स फॉर द JEE एग्जामिनेशन, उसका वीडियो चाहिए तो डिस्क्रिप्शन कमेंट सेक्शन में जाके कमेंट करना, ठीक है. सो विद दिस आई टेक अ लीव फ्रॉम टुडेस लेक्चर. थैंक यू.